Okay, we have a Cocker Spaniel. Black coat color is dominant, that's capital B dominant, to white lowercase b. Solid coat pattern is dominant, so capital S, to spotted pattern, lowercase s. All right, so it's dihybrid. We have a pretty good description of the alleles. Two genes are located on separate chromosomes, good to know. A male that is black with a solid pattern is crossed with three females. Identify the genotypes of all the parents using the following clues. Genotypes. Okay. So one male, three females. So this dog is okay, making puppies. So here we go. Let's figure out what we know. So we know that the male, according to the description, is black with solid pattern. So what does that mean in terms of genes? Black is dominant. They didn't tell if it was homozygous or heterozygous, so we don't know, but if it's black, we know there's at least one dominant allele. And solid pattern. Okay, so one dominant allele for each trait. Not sure of the second one. Okay, so that's BS. All right, anyways, so now that male is going to then breed with females A, B, and C. So what we got here. So the male is made of female A, and female A is white, solid. Okay, so here's the male. Crossed with the female, who we know is white in color. So we know this about her, and we know, because that's the only way you can be white, right? Solid. We know this. Okay, and they made these puppies. So let's just go ahead and puppies. Two black solid. Okay, black solid. Not a lot of clue there. We do have two of those. Okay. And two that are white. Okay, white solid. All right, well, that's helpful. So these puppies are giving us some information. And this one, not so much, but this set is pretty interesting. So to get white, you have to have the two little b's, right? Well, we know that dad gives one allele and mom gives the other. Mom only has little b's to give, so we'll assume one of these is from her. But that must mean that dad gave the other one, right? So we can go in here and fill this in, because now we know this. So that's good to know. Anything else? Solid. No, well, you don't really know this piece of information because, again, solid is dominant. They could be heterozygous or they could be homozygous. Big S, big S. We don't know. So let's go on to the next one. But we got some of the puzzle figured out here. Okay, same thing. So now we know this about the dad, right? So let's just go ahead and fill in what we know. So that's the dad. This female is black and solid. So black again, we just know that. Solid, we just know that. So it looks like the other female in terms of phenotype. What do the puppies make? They produce a single pup, which is white. Ooh, and spotted. Okay, that's interesting. So one pup, but that one pup is revealing some other information, right? So not shocking, but this is a little revealing, yes? Because now we know that these guys have to be heterozygous, right? They have to be. Still don't know what this one is, but we know that the dad has to be heterozygous, right? Okay, so I'm gonna highlight this with our new information color. Oh, and we also know that mama has to be heterozygous again, because look, that's the only way you're gonna get this white. Okay, cool. So we know that now. Nice. So let's go back up to, can we figure out, okay, well, we figured this out thanks to this second set of crosses. Do we know this now? Nope. Still don't know this. We might not know that about the mama, right? Because solid. Yeah. Yeah. That's not really helpful for that. So we might not ever actually know that one. All right. Now, so we know a lot about the dad now. We now know that the dad is heterozygous for the traits thanks to the other crosses. Let's just see what's going on with female C. Female C is white and spotted. Okay, so recessive. Down. And here's what they produce. One white solid, one white spotted, one da 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 da. Okay, that really makes sense if you think about it. Because we know the dad for sure, we know the mom for sure. So again, we'll just do a quick Punnett square. Dad's genotypes would be this. I'm sorry, dad's alleles would be this. 4 different possibilities. Sorry, big B with big S, big B with little s, little b with big S, little b with little s. And then the mom only has this. So if you do the Punnett square, it's a really simple Punnett square, and you'd get a 1 to 1 to 1. But let's just do it to prove it. 2, 3, 4 for dad, only 1 possibility for mom. Okay, so mom is this. Sorry, I'm gonna make this. Okay, so mom has that. That's all her eggs are, right? Dad has 4 different possibilities for his gametes. And again, yeah, it makes sense. We would expect one of the pups to be black and solid, one of the pups to be black and spotted, and one of the pups to be white and solid, and one of the pups to be white and spotted. Good. All right, so we can figure out all the genotypes of the parents, except really this one, guys, right? I'm not missing this, am I? We just don't know if the heterozygous or homozygous based on the fact that both the pups ended up solid. So that's the only one really can't figure out for 100%. Could be homozygous for that trait, or she could be heterozygous for that trait. Have to do a test cross or something.